Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azrul bin Muhammad Azam and my is AA20854. So today I will go with present question based on the assignment given. So me myself are doing first circle, which is this circle. We need to create the circle based on the question given. So in step, transfer as a function, one per as the power of 2 and the scope. So we go to the first objective, which is we need to find using this closed loop to find the grade. So in the framework, press on, go to the comma window. So as you can see here, there's a comma window here. The hash equal to tf 0021 to 29 hash equal to, and press enter and you get the 20 per s to the power of 2 plus 2 plus 2s plus 39, and then enter again. So after that we need to type the PZ map hash and grid on to find this graph. So as you can see here, there is a pro zero map, which is this grid or pro zero map is for the first second. So with the framework, let's on to the next objective. So for the next objective is objective 2, using the same circuit as myself. So with in objective 2, we need to find the start response based on the closed loop system. So as you can see here, there is a common window left side, d equal to tf 0110, and then enter, and then you get 1 for s to the power of 2, and type t feedback g1, and then enter, you get a 1 per s to the power of 2 plus 1, and then enter again. So after you enter, you need to type the t is equal to 0, 0, 0, 1, 1, 0, and then enter with semicolon at the end, and then type step, and then open t bigger and t. So enter again. So after the step you enter, you will get this graph, which is the step response for the closed loop system. And then if you want to know the rest time when or peak time when, just type sys equal to tf 1110 as the t equal to 1 for s to the power of 2 plus 1, and then s equal to step info sys, and then so that you press enter, you get the value of the rest time, peak time. So we go into the next objective. So we go on to the objective 3, which is we need to find the closed loop system used with the PID controller. So my circuit is a circle first. So circle first is suitable with the PID controller. So for that, we create the circuit and just edit the PID control before the transfer function. So we go to command window. So we can see that this is my command window. So first of all, G2 equal to TF, and then 250, 1450, and then enter, you get this one. Then we go to PID, G1 equal to PID 10, 10, 1, and then enter, you get this one with the KP plus KI multiple 1 per S plus KD multiple S. So you can see KP is 10, KI 10, KD 1. So then we enter, you get the G1, you type the TF G1, and you enter, you get the 200, this equation, and then we get this and then after that you type t equal to 0, 0, 0, 1, 2, semicolon, and then you take, and then enter step tt, you get the response. Here you can see here is the start response. The amplitude is 1.01, and then the second amplitude is here 0.197, sorry, here. So after that, if you want to know about press time, you can type s equal to step info t, and then it will go like this: press time, certain time, certain min, certain max, overshoot, undershoot, peak time. So you can conclude using this thing to find to know the rise time and the peak time when the graph will peak, and the rise time when. So that's all for me. I will pass it my friend. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Sawan Hafizi bin Awal Zakaria. My metric number is AA200304. So I will continue for the number 2. So for the first one, the objective is to find the closed loop system is stable or not using zero plot. So firstly we do this simulating model as the question given. So we put step, subsite, function, and scope like this, and then so we open the command window. So we type h equal to tf bracket 0020, 1, 2, and 29. So enter, we got this continuous time transfer function, and after that we type pz map bracket h, and we enter, and then we click on. So it will pop like this. So then we got the polar zero map. So this shows that our system is stable. So that's all for the objective one. Okay, I will continue for the objective number 2. So objective number 2 is to find the step response for the system. So firstly, we do a simulate like the equation given, and then the step which is the step time to 0, and then we apply subtract and the transfer function which is the numerator to 20, denominator 1 to 9. Okay, after that, we write after we done compiling, run, and then we open the scope. So this is I'm using the simulate, and then if I'm using the command window, so firstly we type g equal to f 20, 1 to 9, and then t equal to feedback bracket g, 1, and then t equal to 0, 0.01, and 10, and then step t, and then like this step response. So and then if we want to get the rise time, overshoot, and others, so first we type SYS equal to f 20, 1 to 9, and then enter. Then we type step SYS, and then S equal to step info SYS, and then show the rise time, certain minimum, certain max, overshoot, undershoot, peak, and peak time. Okay, that's all for the objective number 2. Okay, so I will continue for the objective number 3. To implement a controller in the system, so I implement a PID controller. So and then the command window is G2 equal to TF 20, 1 to 9, and enter. And then I do G1 equal to PID bracket 1, 1, 1, and then G equal to G1 times G2, and then T feedback G, 1, and then T equal to 0, 0 0.00, 0.01, and 2, and then step bracket T, and then we'll pop up this graph like this. So to determine the overshoot and the others, so S equal to step info bracket T, so it show the rise time, certain time, certain minimum, certain max, overshoot, undershoot, peak, and peak time. So that's all from me for this question number 2. So thank you.
S squared plus 4s plus 15 s is initial function. Then the scope subtract and step into the second and into the scope. Come over and then you type this F and bracket 2, 50, and then you bracket 1 function into, then you press the enter, will get this answer. Get this, get that, you type the PZ, put 0, this, plug in and do it on. After you press the enter, you will get the put 0 back, this 20s. So that's in this is the differential function. You can push it for the question number 3 and question number 2. For this question, we need to find the response based on the system. Before this, we still use the circuit as we look at the objective. Okay, first thing first, you need to type this at the command window. G equal to TF 0020, 1 to 9, press enter, and then you will get 20 divided by s squared plus 2s plus 9. Okay, this is the continuous time transfer function. Okay, then let's type t equal to feedback G1, and then you get 20 divided by s squared plus 2s plus 29, and then enter, and then you type t equal to 0, 0, 0, 1, then press enter, and the last thing you need to type the step in bracket capital T, T, and then press enter. After you press the enter, you will get the start response. You can see on the right side is the start response that we get on the machine. Then we can do updating number 2, okay? Okay. The last slide is the start response closed loop system in MATLAB.net. And this is the start response closed loop system in Simulink. Okay, thank you, Mr. for auditing. Now we continue with the bodies of the controller on the CPU. For the controller, the F250, 1, 450, then press enter, then we get 250 for the S squared plus 4S plus 50. Okay, then we get G1 equal to ID, bracket 10, 10, 1, press enter. Until press enter, we get this Q2 plus QI, multiplied by 1 plus plus 3 multiplied by S. Okay, after that, we need to have the G equal to 0 multiplied by G2 plus enter, and then we will get the 250 S squared plus 200, 2500 S plus 2500 S plus 4S squared plus HTS. Next, we will get T equal to feedback, bracket, capital G1 plus bracket. And then, after you press the enter, you will get this answer as before, which is 250 S squared plus 2500 S plus 2500 S plus 250 S squared plus 2550 S plus 2000. So after you get that, you have to have T equal to time equal to 0, 0, then 0, 1, 2. Then you start the step, bracket, capital T, and then press enter. After you press enter, you will get the step response for this objective. So you can see on the left, at the left side, you will get the response for everything. You can see the step from
Assalamualaikum warahmatullahi wabarakatuh. My name is Amir Shafi bin Abdul Razak and my project number AA201047. So I'm going to present the closed loop system for now is the objective one, which is to determine stability of a closed loop control system using pole zero flow. And this is our block diagram, just like the question given. This is our mathematical calculation using characteristic equation to determine the poles and zeros. To sketch the pole zero for closed loop system 4. So we get zeros equal to 250 S plus 500 and poles negative 8.052, 1.026 plus 8.571 I and 1.026 minus 8.571 I. And this is our graph of pole zero that I sketch. For the common window, we just type like this: h equal to transfer function in bracket 0, 0, 250, 500, 1, 6, 58, and 600. Then we got the continuous transfer function. When we continue with the PZ map h, then we got the pole zero map. So then we just type again create one. And this is the graph that we get from the common window. Then we just plot like this, and we got the stem, pole, and pin shape. So that's all from me for objective number 1. Thank you. Next, for objective 2, we must simulate the closed loop system to obtain the step response. Firstly, we go to the Simulink model, click the step, then change step time to 0, and then click OK. and run the simulation. Then click the scope. This is the graph for scope. For the common window, we just go to the common window part. Then we just type G equal to transfer function in bracket 0, 0, 250, 1, 4, and 50. Close the bracket. Then we got the continuous time transfer function. And then we write H equal to transfer function in bracket 0, 0, 2, and 0, 1, 2, and close the bracket. Then we get H equal to 2 per S plus 2. This is the continuous time transfer function. And we write the T equal to feedback G H, then we got another continuous time transfer function. Then we write T equal to 0, 0 0.01, 10. Then step in bracket T. This is the step response graph. So we can plot like this. This is the step response graph. Next, we must find for the stable closed system. We must determine whether it is undampened or overdampened or critically dampened. So for this, based on the data from the MATLAB command and Simulink projects, as well as the pole zero plot in objective 1, the closed system 4 has been confirmed to be unstable. It can be categorized as undampened, overdampened, or critically dampened as a result. Next, we also must determine and tabulate the overshoots, percents, spin times, and rest times, and steady state error. So for closed systems, stable, unstable, marginally stable. So unstable. Overshoot, MP% is none, rest time none, setting time none, and we have low steady state error. So that's all for the objective number 2. Thank you. Lastly, for the objective 3 is to implement the P or PD or PID controller to meet the control system design requirement. So firstly, we go to the Simulink model. We just add the PID controller block, then click the PID and choose PID. Then why we choose PID? Because the suitable controller, because PID controller is the suitable controller to make control system in design for. So we go to the command window. We type G3 equal to transfer function in bracket 250, 1, 4, and 50, close the bracket, and then we got the continuous time transfer function. Next, G2 equal to transfer function 2, 1, 2. Then G1 equal to PID in bracket 40, 1, and 0. Then we got the continuous time PI controller in parallel form. Next, G4 equal to G1 multiple G2. We got the continuous time function. Next, G equal to G4 minus G3. Then T equal to feedback in bracket G1. Then T equal to 0, 0.01, 2. Then step T, C. Then we got the step response graph like this. Next, we must tabulate the new values for overshoots, setting time, rest time, and steady state error. So we continue with SYS transfer function equal to transfer function in bracket 1, 1, 0, 1, close the bracket, and then A equal to step in bracket SYS, and the last one B equal to step info in bracket A. So we got the new values like the question given. So we just plot in the table given, which is the overshoot is 1.1111 E plus 16, setting time is 4.0002 E plus 3, the rest time is 2.9421 E minus 15, and the steady state error is 0. So that's it from me, and thank you.